Now, in a column-oriented database, the data types of data elements stored together in those 1 meg blocks that we mentioned all have the same data type. This opens up another performance benefit. Having each block of storage contain data of all the same data type means that compression is much more effective, and much more actual information can be stored in a single block of storage. Storing salaries, as in our aggregate example, means that column compression can use an approach optimized for numbers alone, not having to worry about varchars, chars, blobs, and any other random type of data that might be stored across row. The same goes for a column that would be dedicated to varchar type content. Effective compression speeds disk reads and writes, improves effectiveness of data as it's read into memory, and greatly reduces the overhead associated with the redistribution step as part of query optimization. That step needed for joins and movement between nodes. Redshift even gives you the ability to customize how your compression is applied and analyze the best approach for compression. Now again, this is somewhat of a heady topic, so we're going to save that for the performance-oriented companion course. But through all of this, the point that I really want to drive home as we wrap up this first module is simply this. Amazon Redshift is engineered from the ground up to be a data warehousing OLAP database. And at that job, it really shines. If you find yourself getting caught up with the limitations of enforcement of data integrity through primary and foreign keys, or the missing aspects of non-clustered indexes, it's possible that you're bringing too many OLTP type concepts into the mix. Now, I'm not saying Redshift is perfect. It probably does have many areas where it could mature and continue to improve, but right out of the gate, it is a very effective data store if you let go of some of that OLTP type devotion that you have come to accept as simply law of relational databases. All right, in our next module, we're going to go ahead and finish up our schema design. I'm going to go ahead and put that down into a script that you can download. There's going to be about 15, 16 total dimension and fact tables. Now, I'm going to pre-pick some sort keys and some distribution keys, but I encourage you to take a look at it because you might have some different ideas and some different theories about which joins and which relationships are going to be leveraged over others. And you might have preferences for how some of those queries could leverage those sort keys. After all, we're building this Abacus data warehouse together. And once we populate that schema into Redshift and start loading data, it'll be a little bit harder to undo. Not impossible, and there are ways, and we'll even cover those in the next module. But with some of these architectural considerations out of the way, we're going to start focusing on loading data and getting our ETL to pump data right into this Redshift data warehouse. And look at that, in probably just under about 40 minutes, you have gone from being completely new to Amazon Redshift to having a really good understanding of what it is, what it does, what its limitations are, but hopefully what some of its potential is too. And we're going to drive that home as we go forward. All right, see you in the next module.